Okay, these problems have to do with something we learned at the very end of the year, that these parallel lines really cut the sides, the left and the right side of this triangle proportionally. So we just have to set up a bunch of proportions here to get it to work. So I'm going to go 54 is to 72. As, sorry to get this wrong. You could do it this way. You're supposed to do it this way. 54 is to 36, as 72 is to W. And to do the cross multiplication on that, you get the answer of W equals 48. So this is 48. Okay, now you can set up another proportion using that if you want. So I'm going to do 54. I'm going to show you a couple of different ways to do this. 54 is to 27, as 72 is to X. I'm going to use the original numbers. Okay, just to show you a different way. And this ends up being X is 36. And the last way I'm going to show you to do this is to just, you can use some of the answers you just calculated. For instance, 27 is to 45, as 36 is to Y. You calculate Y and you get, let's see here, 60. Now, the only problem here that can be a bit confusing is the last one, Z. Now, Z problem is a little harder because it deals with an entire length of Z. That's a whole side. Everything we've been doing are parts. You have to be a little bit careful here. We're looking for a side to a side. So I'm going to use 54, the side of this triangle, and I need to compare it to the entire side right there. Okay? And I don't know what that total is. Let me get it for you. So that entire total is 162. Now we'll set that. So this little side is to the big side. As 63 is to C. That's kind of a different concept than we were just going for the previous numbers. So Z ends up being 189. Okay? Okay, and finally, this one, 148, says that the dimensions of the smallest number are 2/3 the dimensions of the larger one. That's a little confusing the way they word that, but in other words, this is 2. If this were 2, this would be 3 heights. Or the radius is a ratio of 2 to 3, 2/3. So that is just the ratio of their sides or heights, so it's one-dimensional. And if we want to find the volume, we're going to have to cube this. So that'll give us the new ratio of cube the 2. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. This is the volume ratio. So now we can use this volume ratio and set it equal to one of the actual volumes. It says the volume of the larger one is 540 pi. Find the volume of the smaller one. So find the volume of the small one. So that's just a little cross multiplication problem which you can do, and you end up with a volume of 160 pi. Okay. The next one. It says Bob wants to find the height of a tree. He stands 20 feet away from a 10-foot fence that is between him and the tree. The fence is 30 feet from the tree, Bob's feet. The top of the fence and the top of the tree are collinear. Sketch a picture and find the height of the tree. All right, so this is definitely something that can be confusing if you don't draw a picture. So I'm going to draw the picture and come back to you to complete it. Okay, so what I think made this problem a little bit confusing is it said that from the bottom of his feet to the top of the fence to the top of the tree are collinear. And so finally I think we have the picture. And so that was the hardest part. So now we just have to, these triangles are similar, the little one and the entire thing. So we have to set up a proportion of 20 is to 50, right? It's 50, as 10 is to x, is beating x, height of the tree. So you go ahead and you do that, and you'll notice that this is x, I think, is 25 feet in height.